I made a video a while ago on using tile maps in 3D in GameMaker, and the main idea is pretty simple. You can use the draw tile map function to manually draw a tile map with a perspective projection set, and GameMaker will, for the most part, take care of the rest. But sometimes it might be desirable to take a tile map that you might find in a GameMaker room and turn it into a vertex buffer. And to be honest, this isn't something you'll need to do very often. There's not a ton of advantages to be gained from turning a GameMaker tile map into a vertex buffer, and it also means that you can't take advantage of some of the things that you can do with tile maps, such as being able to easily change them on the fly, or even having animated tiles. But since when has this channel ever been about shying away from information just because I don't think it's very useful? Let's talk about turning tile maps into vertex buffers. So I'm going to actually do this in two parts. I'm going to make one video on the basics of iterating over a tile map in GameMaker and extracting basically the tile information out of it. And I'm going to make another video on making use of some of the more specific features of tile maps, such as if you were to use the mirror or flip tools for a tile or something like that. I'm also going to be assuming that you have some knowledge of how 3D and GameMaker works, in particular how UV coordinates work, how texture coordinates work. I'll take a few minutes to explain a brief crash course overview of what our UVs are going to be doing, but if the first question on your mind right now is what on earth is a UV coordinate, then you might want to go back and watch some of the previous videos that I've made on the subject. So each of these tiles in the tile map that I'm going to be turning into a vertex buffer, we're going to be iterating over the tile map horizontally and vertically, so we're going to do a double for loop for the width and the height. And for each tile in the tile map, I'm going to turn it into essentially two triangles, 6 vertices. And one of the triangles, I guess I'll zoom in on one and slap a little doodle over it. The origin's going to be in the upper left, and one of the triangles that we're going to create to cover the tile is going to be the upper left, the upper right, and the lower right. It's going to enclose those 3 vertices, and the second triangle is going to be the opposite. So that's going to be the lower right, the lower left, and the upper left. Strictly speaking, you could go the opposite way if you wanted, but this is the convention that I always go with when turning a quad into 2 triangles, and for the sake of consistency, it's good to do the same thing every time. So as for some limitations, there's one real limitation for what I'm going to call the simple tile map to vertex buffer code that I'm going to write in this video, and I will amend this in the second video. But when you create a tile set for the first time, you have a couple different properties that you can set. You have the tile width, height, offset, separation. These are the width, height, offset, and separation have to do with how your sprite graphic is divided up into tiles, but the last two, the output border X and the output border Y, have to do with how your tile set is written to a texture page. And for now, I'm going to set these both to 0. By default, I believe it's 2, and with a little bit of UV magic, it's not too hard to compensate for that, but to keep things simple for today, I'm going to automatically set those to 0. As for everything else, you can leave that as it is. It doesn't matter if your tile set is on its own separate texture page or if it's grouped with something else. It doesn't matter if you are or aren't disabling source sprite export. But if you want to get the correct results today, make sure that the output border X and output border Y is set to 0. I'll explain what that is for at a future time. Anyway, I guess I'll get started and I'll go create myself another script. Let's call this tile map to vertex buffer. And I'm going to give this function, let's full screen this because I'm not going to be working with anything outside of this today. I'm going to be giving this function 2 arguments. One is going to be the layer name, and another is going to be the vertex format. So the layer name is, if you were to go into the room editor, in my case, tiles 1, you could give this your own name. We could call it something like ground tiles. And when we call the tile map to vertex buffer function, we're going to pass in that layer name as a string. The vertex format, if you've worked with 3D and GameMaker before, you've no doubt had to deal with many, many vertex formats before. Position, normal, texture coordinate, and color are kind of the 36-byte standard. We'll be going with that. And I guess if I were to let's say, create a tile map vertex buffer. The way that we would call this would be that we would say tilemap to vertex buffer. We could give it a name, which is ground tiles, and our vertex format is the one that I created up here. Position, normal, texture, coordinate, and color. And that's just going to be called vertex format. And then when you go to draw the tile map, right now I'm using the draw tile map function to draw the tile map itself in 3D, as I mentioned, but should you convert your tile map to a vertex buffer, what did I call it? The variable storing that is going to be tilemap underscore VB. PR triangle list is the primitive type. And the texture is going to be, we have a function tile set get texture. What's it called? TS underscore main. And that's going to draw our tile set vertex buffer, our tile map vertex buffer. In case anybody hasn't, like, actually actively thought about this before, the difference between a tile set and a tile map, a tile set is the data which represents all the different tiles that you might pull out of a sprite. So the tile set is the GameMaker asset type, and the tile map is the layer in the GameMaker room editor which you can stick tiles on. And that's going to be the difference between a tile set and a tile map. I will be talking about both of them for specific purposes in this video, so we're going to want to make sure that those are straight. So I'm going to have to do quite a bit of setup before I really get to looping over a tile map and converting it to a vertex buffer. The first thing I'm going to do is we have our layer name. We need to turn that into an actual tile map. And I can do that by saying, let's call it tile map is equal to layer get ID of the layer name. And this is going to get the layer, the actual layer data that's associated with that string representing the name. That's going to allow us to actually get the information from a tile map. Technically, GameMaker can get all the relevant tile map information just from the layer name if you were to use the layer name in the various functions that I'm about to write after this, but it feels like good practice to get a reference to the actual layer and a reference to the actual tile map before doing that. There's also, I'm going to call this tm underscore depth, is layer get depth from the tile map layer. So this is the depth in the room editor. If you're working with tile maps in 3D, you may or may not want to actually respect the tile map's depth the way that you would in 2D. You may wish to draw all tile maps at depth equals 0. If you wanted to do that, you could edit this line of code to just say that depth is going to be 0, but for the sake of completion, I'm going to be getting the actual layer depth. Next, I'm going to get the tile set information from the tile map. So this is the tile set used by the tile map. If you had a tile layer with multiple tile sets defined in the asset browser, you could swap between them, and you could either reskin your level using different tile sets, but the same tile map, or you could achieve a crazy glitch city look by using the wrong tile set on a tile map and drawing just random bits of random graphics all over the place, and it'll look really weird. The tile set used by a tile map you can get by saying tile map get tile set, and you can pass it the tile map ID or the layer ID. I am going to be prefixing all of the variables which pertain to a tile map with tm underscore, and all of the variables which pertain to a tile set with ts underscore. Once again, this is a convention that should help keep straight what properties relate to what. So we can say ts info. Instead of having a million different like tile set get width, tile set get height, tile set get whatever functions, there is a function called tile set get info, which you could use on a tile set, and that will return a struct which will show you all kinds of different bits of information about the tile set relating to things like the tile size and a few properties relating to how it's been written to the texture page. For example, the width of the tile, the width of each tile, ts tile width, I'll call it. You can figure that out with the .tile width variable that you get out of the struct that you get from tileset getInfo. GameMaker, this is one of those things where it feels like GameMaker is like in the middle of transitioning from a set of procedural functions like tileset get whatever to making everything struct based and putting properties like this inside the tileset getInfo struct. I have mixed feelings about that. I feel like I should wait until new runtime comes out properly before I really judge GameMaker on how it's making that transition. But nevertheless, TS tile height is going to be TS info.tile height. And also, if you are watching this video after the new runtime comes out, how do you like it? I hope it's good. It looks like an opportunity that GameMaker has to really clean up a lot of this legacy baggage in the language. Anyway, where was I? So next I'm going to want to get the horizontal count, the horizontal tile count when the tile set is written to a texture page. So TS, I'm going to just call it horizontal count, TS info dot tile columns. This differs from the number of tiles in a column in like the tile set source image. So in this basic ground tile sprite that I have, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tiles laid out in columns in this graphic. But that won't necessarily be how it's laid out on the texture page. GameMaker may or may not rearrange these tiles as it sees fit. If I were to go to, I want to say if I were to go to Windows Options, Graphics, and then preview the texture page, it will take GameMaker a minute to run the ISO compiler, and then I will be able to look on the texture page at how this is laid out. And we can see that in addition to the font with all the fancy characters and whatnot on it, the tile set has not been written out onto the texture page the same way that it looks as it exists in the editor here. So I believe we're going to have 1, 2, 3, 4, 5, 6, 7. I want to say there's 8 tiles in a 8 columns of tiles here, and that will be the value that you get inside the tsinfo.tile column. So the horizontal tile count property variable here. So that's getting some information about the dimensions of the tile set and the dimensions of each of the tiles. Next, I'm going to say var ts underscore uvs is tile set get uvs. This is sadly not some information that is returned by the struct from tileset getInfo. I kind of wish that it would be, just so that all this information could be contained within like that one struct over there, but alas. So tileset getUVs is going to return an array, which is going to contain some information about where the tileset is written onto the texture page. So the UV coordinate of the upper left, or I should say the horizontal texture coordinate of the left side of the tileset is going to be in index 0 of this array. So I can say var ts UVs left is going to be index 0 in that array. The texture coordinate of the top of the tile set, so we can say tsuv's top is going to be index 1 in that array, and the right side is going to be index 2, and the bottom is going to be, as you probably would have guessed, index 3. So index 0 and 1 are going to be the UV coordinates of the upper left of the tile set, and indices 2 and 3 are going to be the bottom right. And that's going to be relevant when we try and figure out how to map the texture coordinates onto the vertex buffer for each tile. Next, I'm going to want the actual texture information that goes with the tile set. So we can say ts underscore texture is going to be tile set get texture. This is going to be a reference to the texture page itself. That's what we're going to need to supply when we say like vertex submit, for example. And we're going to need to know 2 bits of information about the texture itself, we're going to need the texel width and the texel height. So I can say var ts texel width is going to be texture get texel width, and texel height is going to be texture get texel height. So this is going to be the width and height of each texel. You can think of this as 1 over the width and height of the actual texture page itself. So if your texture page has a dimension of, let's say, 64 by 32, this one's a little bit bigger than that, but the texel width is going to be 1 over 64 because texture coordinates range from 0 to 1, so the texel width is going to be 1 over the width of the texture image, and the textural height, in that case, will be 1 over 32 for the same reason. I'm also going to want the texel width and height of each of the tiles, and I can get that by saying ts texel width multiplied by ts tile width. So this is the texel width multiplied by the number of pixels in each tile, the width of each tile. So if we have that texture page, which is filled by, let's say, tiles of size 16 by 16, then the texel width of each tile is going to be 16 multiplied by 1 over 64, which is to say 16 over 64, which is going to be 1/4, and the texel height is going to be 16 high multiplied by 1 over 32, which is 16 over 32, and that's going to be the texel height of each tile. TS texel tile height. I want to be TS texel height multiplied TS tile height. That's all of the initial setup I'm going to have to do. Lastly, I want to say TM width is going to be tilemap get width, and TM height is going to be tilemap get height. And this is simply going to be the width and height of the tilemap in tiles. So this is going to be what we're iterating over, essentially. I'm also going to need to say var vbuff is going to be vertex create buffer, and that's the vertex buffer that we're going to be stuffing data into. Vertex begin vbuff. The format is going to be the vertex format. And now we can begin the process of iterating over the tile map and populating the vertex buffer with each tile. So let's create 2 nested for loops. So for var I equals 0, I is less than tm underscore width, I plus plus. For var j equals 0, j is less than tm underscore height, j plus plus. And this is going to be for each tile in the tile map. We're going to do something with it. So firstly, I can say var, let's call it tile data, is going to be tile map get, and this is going to be a little bit of data for each tile. You can get some information about the tile from the tile data that you get from tile map get. That's going to be the tile map that we're working on. Cell X is going to be I, cell Y is going to be J. There's a couple bits of information that you can get about a tile, but the one that we care about right now is going to be tile get, or let's say tile index is equal to tile get index. From that tile data, this is going to return the index of the tile. So if I were to go back to this this tile set image, these are just going to be numbered, and it's going to go horizontally. So this one over here, the null tile, is going to be index 0, then 1, 2, 3, 4, 5, 6, whatever. And then it's going to wrap around. So the first one on the next row is going to be like 8, 9, 10, 11, 12, 13, 14, and so on, whatever it happens to be. I feel like unless I'm miscounting, I'm only actually seeing 7 tiles on a row here, and I kind of assumed that it would be like 8 or something, some power of 2. But anyway, why did I close that? What we're going to want to do is we're going to want to convert the tile index into a row and column, and from that row and column we can work out the UVs that we're going to need to map onto each of the triangles that we put in the vertex buffer. So let's say var tile index x is equal to tile index mod ts horizontal count. So we're going to do some modular division. We're going to divide tile index by the ts horizontal count and take the remainder. And for tile index y, we can do essentially the opposite of that. Say tile index div ts horizontal count, and that instead of dividing and taking away the remainder, instead of dividing and returning the remainder, integer division is going to divide and throw away the remainder. It's the same thing as regular division rounded down, at least for positive numbers. I don't remember how it works for negatives. And this is going to give us tile index x and y, which is going to correspond to the 2D coordinates of this tile. So we're going to want to turn that into a texture coordinate, and we can do that fairly easily. I'm going to, let's say uv underscore left is going to be equal to ts texel tile width multiplied by tile index x. Var uv top is going to be ts texel tile height multiplied by tile index y. So going back to our earlier example, if the tile texel width is going to be 1/4, and let's say that we have a tile index 2 or something like that, the left UV coordinate for that tile is going to be 0.5, and the same for the top. However, since it is not guaranteed that a tile set is going to take up the entirety of a texture page, and it may live off somewhere in the middle of the texture page, as this one does, you are going to also want to add in ts, what was the variable name? ts UVs left to this calculation, and the same thing for ts UVs top. Can I line up all of these names? That's satisfying. And the top left UV coordinate of the tile set that you get from the tile set get UVs function will just give you the offset on the texture page of where the upper left of the tile set begins, and we can say UV right is going to be equal to UV left plus the ts texel tile width, and var UV bottom is going to be equal to UV top plus ts texel tile height. So the bottom right UV coordinate of a tile is going to be the top left plus the width and height of the tile. So that's all right. We've got the coordinates that we need from the texture UVs for each tile. Now it's time to start thinking about turning them into a vertex buffer. I'm going to define 4 points, and they're going to be point 1 is going to be the upper left, point 2 is going to be the upper right, point 3 is going to be the bottom right, point 4 is going to be the bottom left. So we're going to go clockwise around the tile from the upper left. So I can say, let's start defining some values. P1x is going to be ts tile width multiplied by I. P1y is going to be ts tile height multiplied by j. P2x, var P2x is going to be P1x plus ts tile width. P2y is going to be P1y plus nothing. Var P3x is going to also be equal to P1x plus the tile width, because it's on the far side of the tile from P1. Var P3y is going to be P1y plus ts tile height. And var P4x is going to be P1x plus nothing. And P4y is going to be say P1Y plus tile height. And those are going to be the coordinates in physical game space of each of the corners of the tile. I'm going to do the same thing for the corners, but for the UV coordinates. This is going to be a little bit easier because we've already done a lot of the math here. We can say P1U is going to be UV left. P1V is going to be UV top. P2U is going to be UV right. For P2V is going to be UV top. P3U, UV right. P3V is going to be UV bottom. P4U is going to be UV left. P4V is UV bottom. So now for each of the corners of a tile, we know where the like the physical coordinate in space is, and we also know where the relevant UV coordinate is. And now we can start writing information into the vertex buffer. So this is one of those things about my channel that really shouldn't be controversial. I, since the beginning of making 3D videos about GameMaker, have been carrying around a little function called Vertex add point. And this is a little function that all it really does is it takes an X, Y, Z normals, texture coordinate, and color, and sticks them into a vertex buffer in just one function call. And the whole point of Vertex add point is so that you can just call this function with a couple of arguments and not have to write out vertex position 3D, vertex normal, vertex text coord, vertex color over and over again, because that's a lot of typing. It's very annoying. It leaves space to accidentally put in typos. That's not a lot of fun. And for whatever reason, that has apparently turned into one of the weirder points of confusion about my GameMaker videos. Guys, this function is here for your own convenience. It's not something that's built into GameMaker. It takes like 2 seconds to write. If you've ever come across it in the wild and you've not known what it does before, middle click it. You'll open up the bit of GameMaker code in the project that where it's defined. It does amuse me a little bit how this has turned into basically my version of how does Sean Spaulding's collision code work, but I'm going to use it, confusing or not. So for the first triangle, we're going to be adding 3 points, so that's going to be 0.1, 0.2, 0.3. So if I say vertex add point, the vertex buffer is going to be vbuff. The x is going to be p1x. Y is going to be p1y. And what you put in for the z is a little bit up to you. I did get the tile set depth, the tile map depth, from the tile map. So this is the depth that it would have in the room editor. And you can use that if you want. You can use tile map depth as the z coordinate. Or if you don't care about any of that, you could just hard code it to 0. But I think for the sake of completion, I will go with the depth of the tile map. The normal vector. So if you're not one who really cares about using vertex normals and lighting calculations and that kind of thing, you can kind of just ignore this. If your vertex format does not have a normal component, then don't worry about this. Make sure that you're not trying to add one inside vertex add point. But you could work out the normal vector of a tile on your own if you want. You could take the 2 cross products of each of the edges, and you could normalize that for the normal vector. Or you could assume that if your tile map is lying flat on the XY plane, as it is in GameMaker, your normal vector pointing up out of the tile set is going to be 0, 0, 1. U and V texture coordinates, so P1U, P1V, and color and alpha for each of the tiles. I'm going to go with C underscore white and a alpha value of 1. Tiles in GameMaker, for whatever reason, don't get to have their own blending information. It's something that surprises me once in a while when I'm working with tile sets in GameMaker, but just put in a color of white and an alpha of 1 if you don't have any reason to put in anything otherwise. Again, assuming your vertex format even uses the color attribute. If you're not using the color attribute, then you obviously don't have to worry about that. So this is the first triangle. That's going to be P1, P2, P3. And our second triangle is going to be P3, P4, and P1. So it's going to be the lower right, the lower left, and the upper left. So I'm going to take P3, I'm going to take P1, And I'm going to stick P4 in the middle there. And this is really all you have to do to convert a tile map to a vertex buffer. So this is all we're doing in the loop. To end this off, I'm going to say vertex end. VBuff, I'm going to say vertex freeze. VBuff, because generally freezing a vertex buffer is a good idea. I'm also going to say layer set visible. And I'm going to turn the tile map layer invisible so that it's not going to be drawn automatically when we run the game. And then, of course, return the vertex buffer when we're all done with it. And then we can use it later on. So let me actually run this without submitting that tile map vertex buffer, and we should see that we're still going to have like the trees and stuff in the world, but we won't have the ground. Okay, ground has disappeared, and after I do this, after I convert the tile map to the vertex buffer, I should be able to uncomment this. I should be able to draw it, and we should have all the tiles in the correct place. All right, that's really cool. You can go through this tile map looking at the positions of each of the like flowers and patches of sand and whatever, and the puddle over there, and everything should be in the correct place. All right, so that's pretty fun. Limitations of this, obviously, this is pretty good, as I mentioned. I didn't notice any visible artifacts when I was walking around. Maybe if I were to look closer at some specific tiles, I might notice some, but even looking closely, I don't notice any. Sometimes, if you have your tile set padding, or your output border X and output border Y set to 0, it's possible that you'll see seams in your tiles in your vertex buffer if there's no padding between them, caused by adjacent tiles, tiny slivers of pixels from adjacent tiles bleeding over. And to get around that, that is what you would set your output border for. That is what you would add padding to your tiles for. And generally, it's a good idea to do that to prevent bleed over, but it does make the math for calculating the tile set UV slightly more complicated, which is why I'm going to put it off for a future video. Another thing you can't do, if you were to, and I think I mentioned this at the beginning, but if you were to, let's say, put down a tile, and if you were to flip vertically, that didn't do anything because that's got, well, it's very close to vertical symmetry. It's not quite. But if you were to mirror your tile horizontally, or if you were to rotate your tile in some way, there is no code in here that would account for that. That's another thing that's fairly easy to do, but I'm going to put it off for another video because it's a little bit of math. And if I were to run the game now and look at these flowers, you would see that they are not flipped or rotated in any way. They are all standing up the same way. And that is something that you probably want. Honestly, it's probably not going to be too hard if you've gotten this far to figure out how to flip, rotate, or mirror a tile on your own. It's just a little bit of moving some values around, but I will save that for another video all the same. And another thing that this doesn't account for is any tile animation. And I guess I can add one here. So let's add an animation. The number of frames, let's just go with 2, and I'll select those two flowers. And if we go with like 4 frames per second, they'll like flicker back and forth between those two designs. If you were to draw the tile map like the normal way, the GameMaker way, then you would see these flowers animating. You would see them flickering between frames. But if I'm going to use this code I have here to convert a tile map to a vertex buffer, it won't, because again, there's no code involved to tell GameMaker about any tile animation. I'm not 100% sure if I want to. Can I undo a bunch of stuff here? I'm not entirely sure if I want to include tile animation in the final version of this. Are we? Oh, am I still setting this to invisible? Let's just comment that out for now. Anyway, I'm not entirely sure if I want to do tile animation in the final version of this, but just know that it is a limitation of the system. Alright, it's really weird to see those flickering back and forth like that. I think we're going to stop. So that's the basics of writing a GameMaker tile map to a Vertex buffer if you ever wanted to do that. It is something that can be useful once in a while. GameMaker's built-in tile map system is actually fairly good. It's not quite as fast as submitting a Vertex buffer, but it is very flexible and allows you to do things like animate tiles or change tiles on the fly without too much work. But if you did ever want to convert one to a Vertex buffer, this is how you do it. I'm going to end this off here. My name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the video, or the GitHub repository in the video description. I try to post about 2 game dev videos a week, one tutorial like this, usually involving the weird 3D things you can do in GameMaker, and one Let's Make a Game, currently a 3D Zelda-like platformer sort of game. So if you're into any of that, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. I hope you all found this useful, and I will see you all later. Special thanks to Army Armbuster, DJ Gibbles, Edward Holt, GameMaker, Manta Ray, Syndra Larson, Squarecrow, Vitro V, and Zenjament for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.